Um, Today we are going to look at 10.2. This is about drawing a best fitting line for the given data points. So last time in 10.1, we were looking at the pattern or the relationship between the given two variables. We were interested in linear relationship, right? So then after that, we saw how to find the little r, the correlation coefficient, right, for the sample uh, data. Now here, if you have sample data points, now we are going to look at how to draw a best fitting line among those given data points, right? So the best fitting line means, look at this figure. You are given a lot of data points, right? So now if you could draw a single line, of course, it is very difficult to draw a line, passing through all the points because, the points are kind of scattered everywhere. So the thing is now we are going to, make the better, estimated linear, equation, right? By looking at your given data points. So that estimated linear, a function or line is called the best fitting line. Okay. So now, before going to do the remaining, so let's look at the definition of some terms here. So we all know that the straight line formula is given by y is equal ax plus b, right? We are going to look at, kind of a formula here. We need to derive, actually, we need to figure out, we need to find out these kind of formulas, right? Remember, you'll be given data points x, right? Based on your data points x and the y, we are going to find out the equation of the line. Okay. So the best fitting line, let me call that name y as a y prime. Okay. So we use y prime if you look at here. The y prime is, we are predicting my y value based on the given x and y. Okay. So now I'm predicting my y prime by looking at the data values, right? So this y prime is called the predicted value. We don't know. We are just, guessing. But I'm using a little y as my observed value. Observed value means this y value is coming from your data points, right? The y coordinate of your data point. So this is, of course, given. This is I'm predicting, guessing, right? So remember, kind of you are estimating y prime by using y. So this is actual value. So there should be a difference between y prime and y. That difference is called the residual. Okay, so residual means the difference between your observed value, actual value. In other words, so we call this as observed value or actual value. So the difference between the actual or observed value and the predicted value is residual. So in terms of the symbolic way, I could write this as y minus y prime. Okay, so this is the residual or residual error, whatever you can call it. So residual. So residual means that is the predicted error. So you could use either word. Okay. Okay. So some textbook they use little e for the residual. Okay. So now this is the thing. So my task is to now, finding the best fitting line. Okay. So now how are we going to find the best fitting line? This equation. So we've used one method. That method is called um, um, the method of linear square. That means whatever you have the error, so that error should be smaller. So we have to make this error as much as smaller. So that means you need to make this difference, small. in such a way we are finding this line. Okay, so that is our task now, finding this line by making the residual error as the minimum value. Okay, so now let's look at this picture. You are given some data points. You see here data points. Suppose if you know the best fitting line, right, the line that passes very close to the given data points. So now this is my observed, sorry, this is my not observed, that is were predicted, right? So now this is my y prime line, the predicted equation of this straight line, right? So now this is my predicted. But if you look at, for example, look at this data point. This is the actual data point you have, but this is my predicted line, right? Suppose if you find one, the point on this predicted line based on your x value, right? So the line is here, my predicted y value is here, actual y value is here. The difference between, the actual and your predicted value, this is my residual for this particular point, okay? And so on. So if you look at this point, right, this is your actual point. So the x coordinate is here, right? The y value is here. But if you look at the y value for this, particular x on your line, that is somewhere here. So now this is your predicted, y value, that is y prime. So this is actual y. So again, you are getting the error, the difference, right? So this is my the residual for the second point, and so on, right? My task is to now minimize, in general, to minimize these, these errors. Okay, so my task is to minimize these all the sum of error. That is my task. Okay, so then we use the linear, the least square linear procedure to find out this. So remember I told you earlier, my task is to find this line, right? That means you should know these two guys. We don't know. We need to figure out these two. How do you figure out these two? Based on your data points. Okay. So now how are we going to figure out the coefficient or the slope of the line here, A, that is given by this massive formula, right? Look at these two formulas, finding A and B. So the A is given by what? The summation of all the Y data points, then multiply the summation of the square of all the X values, then subtract, what? The summation of X, then times the summation of X times Y. Okay. Now we are dividing these all by n times the summation of x squared minus x whole thing squared. So this is a massive formula to calculate A, right? In similar way, you could calculate B also. Let me write down that also, in times the summation xy, then minus x and summation y over n times summation x squared, right, and minus. Okay, so now these all x and y's are coming from your data points sample, right? By looking at that, you will calculate A and B. So once you know A and B, plugging those two values into formula, you will get the best fitting line. So that is our task now. Okay, so now look at this example. Which example they are taking? So do you remember this problem last time we did?
Yes, sir, from the last section.
Yes. So we had if I could remember correctly. So we had that six car making companies. Then we had the data values. Do you remember? Okay. So if you want, I could insert that 10.1. Okay. So this is 10.1. So let me go through that problem. Where's that? Okay, so this is the data values. So we are going to find the best fitting line for this problem. Okay, this example. So basically, you have a 1, 2, 3, 4, 5, 6, 6 data points. So little n is 6, and these are the values you x and y. We are going to make these x and y data values to find what? Find the a and b, right? We are going to estimate a and b. That's my task. Once you know a and b, we will write the best fitting line. Okay. So you could look at these data values. Okay. So now let me go through this. Okay, so we are going to use those data values. So therefore, n is 6 there. The summation x, all the x data values is 153.8 we had last time. Summation y is 10.7. Then product of the summation of xy is 682.77. And after that, we had the summation of x squared is 5,859. These are all the values we got last time. Okay. So now I'm going to use these two formulas and plugging those values, right? Summation y, summation x squared, summation x, and summation xy, and so on. So if you're plugging all the numbers, you will get this big fraction, and you will simplify everything, and you will find out a. In similar way, we got b also. Once you know a and b, so my best fitting line, regression line, is going to be y prime is a plus bx. So a is now 0.396 and b is that. Okay. So now this is best fitting line. Once you have the equation of the straight line, we know how to draw a straight line equation if you are given, right? So this is my equation of the straight line. The slope is now 0.396. Sorry, the slope is 0.106 and the y-intercept is 0.396. Okay, so that means what? That means if you extend this straight line like that, so it will intersect y-axis at 0.396. So this is my y prime. Okay, so why we use this, the best fitting line? Suppose if you have one more x value, right? Suppose if you want to predict some y value, if you are given some x data point, suppose say you have one data point somewhere. Say my data value x value is in future, maybe. So say my x is say 40. Suppose if you are looking at your predicted y value, that is y prime, by looking at this data point x value. So that means you could figure out, right? You could predict this by looking at the line already I have drawn here. So you have to look at your point x is 40. So this is my x-axis, right? So 40 will be somewhere here, right? So if this is x40, then you will look for corresponding y value on your straight line. So this is the y value. You will check the y value, right? After finding on the line. So this is the corresponding, the y prime you will predict. So you could predict the future if you know the best fitting line. So that is kind of our task, right? Prediction. So this is very, very useful, right? Suppose say two variables, say x is the number of the production cars, right? Suppose you think like this in future, say in 2022. So we are thinking, okay, suppose if you produce, say you are producing 50,000 cars, right, in future, how much profit I could expect, right? The profit. Since you have the present data values or past data values, use those past data values x and y, right? So what is here x? The number of cars we had in the past, and you will find the corresponding the profit for this particular year. Then use those past data values, and you will predict the y prime formula. Once you have the y prime formula, we are going to use that predicted value for the future, right? So that is the idea. So let me tell one more thing. You could use, the calculator to find out this in very easiest way. Okay, so now I'm going to use the calculator to find the best fitting line. Okay, so we are going to use the calculator. So for the best fitting line. Okay, so this is the procedure. Go to stat, enter all the data. Right. Now you have two columns, right? L1, L2. This is my X, this is my Y. So after entering again, go to stat and calc. Last time we had to find the little r, right? The same formula. Then you have to go, I believe number 4, right? Last time we used linear regression. Use this function. So we are looking for this one, okay? Then in that enter, then you will find out A what, B what, R squared what, and R. This all will give you. Okay, so we did this, you know, we used this procedure to find little r last time, but same procedure for finding AB also. Okay, so let me show you where's my data values. These are the data values, right? Okay, so I'm going to start edit. Okay, clear. I'm going to enter all my x values. So 63, 29, and 20.8, 19.1, 13.4, and 8.5, right? Okay, then let's move to my y value, that is 7, 3.9, 2.1, 2.8, 1.4, and 1.5, right? So like that, first enter all the values x and y, right? So then, okay, then go to stat again, calc, number 4. So you got A and B, right? So I got my calculator is giving oops, let me go back. Okay. So here, the formula is given here. Exactly, these are the A and B values. So look at our calculator value. Calculator given A is a 0.106. Yes. Let me tell one more thing. Um, oh, no confusion, right? You see, uh, you need to interchange your letters in your calculator answer, right? Why, you know? Calculator is given for y is equals ax plus b. But here our formula says y prime is what? A plus bx. Okay. So this is the formula now we have. So b is literally there a, right? B is the coefficient of x. You see here? B is the coefficient of x. But there, if you use the calculator, the coefficient of x is a. So what I'm trying to say is my b value for here is actually in your calculator is a. So you have to switch those two values to find a and b here. Make sure that you switch those two values. Okay. So the calculator a is basically my b value, right? Therefore, the b value is going to be my slope here. Therefore, my b value, I need the b value for this formula. That is actually my a value from the calculator, which is a 0.106. And my a value for the for the formula is actually a b value from my calculator, that is 0.396. Okay, so these are the two values I got now. So when you once you replace these values, you will get the formula 0.396 plus. So this is the best fitting line by using calculator. Okay, right. The regression line can be used to make the prediction for the dependent variable, right? So we are going to predict for the dependent variable. Dependent is what? Y. right? Basically, literally, we are using y prime here. You should use the guidelines when you are making the prediction. The points of the scatter plot fit the linear regression so reasonably well. So we assume that we are going to find the, the linear. So we assume that there's a linear relationship, right? That means we assume that there's, the significant value for our little r. The value of the specific x is not much beyond the observed value x values, right? That means, particularly, we assume these two are, almost the same. The observed value and the x value I'm using, for the best fitting line. So very much we have to assume that very much close. And the next one is r is not significant. If r is not significant, means what? If r is not significant, then there should be no, the linear relationship between. Remember last time we had that, right? So we had set up to the hypothesis testing last time we had. So if it is significant, you have to have the linear relationship. If it is not significant, there's no linear relationship. So if you see r is not significant, in that case, how do you predict your y value? So to predict your y value for the given specific x, right? To predict your y prime, simply take the mean of your all the y values, right? So this is simply just this, okay? So if it is significant, use the best fitting line. If it is not significant, simply find the prediction, the predicted y value by taking the mean or the average of your all the data points y values. Okay, so that is what this says. Okay, so let me do some problems from this exercise. For each exercise, find the equation of the regression line, best fitting line. Okay, so we are going to predict y prime. That means you need to find out A and B's, right? Okay, so let's do one of these problems. So which one you want? Could you pick one problem from 11 to 14?
Can we do 14?
14, okay. So remember, these are my data values, right? Use these data values to predict what? Predict my y prime. So I'm using the formula A plus bx, right? So A plus bx, so b is my slope and a is intercept. So how are we going to use? We are going to use the calculator, right? Or you could use the manual formula, whatever you like. So how many data points are given? 1, 2, 3, 4, 5, 6, 7, 8. So n is 8. So these are my x and y values, right? So this is my x and this is my y. So let us enter these values into your calculator. Remember the first row, files, right? That is number of files and how much acre are burned, destroyed. So these are the two things. So I'm going to enter my x values into L1 column. Okay, so let us enter our x value: 72, 69, 58, 47, 84, 62, 57, 84, 62, 57, and the last one is 45. So these are my x values. There are 8 values. Now let's move to my y values. So it is going to be 62, 42, 19, 26, 51, 15, 30, and again 15. So we have all the values, right? Now go to the stat and calc number 4, enter. Okay, so we got the estimated A and B. So my A is, let us write down in 3 decimal point. Okay, so now remember, you need to switch the values, right? My formula is, I need actually this A, but in your calculator it is B. So look at the B value, which is negative 31.96 or 46. Then your B is your A value in your calculator, so it is 1.036. Right? Therefore, my predicted equation is A plus BX. So A is negative 31.46 plus B is 1.036 times X. Okay. So what is X here? This is the number of files, and Y prime is the destroy the area of the land. Okay. So now this is the formula we have. Once you have the formula, now we could predict our Y prime if you are given any X value, right? Okay, what is the question here? After estimating your best fitting line, the question is now find Y prime when X is 60. So now you have the formula, right? You have the relationship between Y prime and X. Now they are telling, hey, could you find Y prime if X is 60? Simply plugging 60 into your formula for X, then solve for Y prime. So the Y prime is minus 31.46 and plus 1.036 times my X is now I'm going to plug in 60 here. So simply take your calculator and find out this value. So I need a negative 31.46 and plus and 1.036 then times 60. So this will give you the predicted Y prime, which is 30.7. Okay, so that means what? That means in future, if we have 60, fire problems, then that means we are going to lose 30.7 area of the land. That's the meaning, right? Does it make sense?
Yes, sir.
Yes. So if you want, you could put the units here. What is the unit for my Y prime? So Y values are acres, right? This is just area. So this is, if you want, put the unit. So like that, you need to. So I'm giving now 5 minutes. Could you try one more problem, you guys? Okay, so could you try number 12? I'm waiting, okay? So you have to do that problem and tell me your answer. Okay, do you see my calculator on the screen?
No, not right now. We don't.
Do you see now?
Now we see it.
No?
Nope.
Okay, very good. I am going to do separately. So you do yourself, okay?
Hey, I got a question, Dr. Raj.
Yes, go ahead.
For the A value, which is your B value after you
Oh,
calculate, it's doing the E negative 4.
it's
What's
very, it's a
so what's my
very,
term
yeah, it's
B?
a very small answer, right?
Right. I don't remember exactly how that needs to be written out. I mean,
Okay.
you explained it to us a couple of classes ago, but I could flip back through my notes, but
Okay, so this is the catch. You see the -4 in the exponent, right?
right.
That means you have to move the decimal 4 places towards left.
Okay.
Okay, so you're going to tell me the answer. So remember, we are looking for y prime. That is a plus bx, my formula here. So a and b values. A value is literally the b value of your calculator. So if you look at your calculator b value, what is the answer you got? One of you.
You want the answer it told us or the answer after we swap it?
I need just the decimal place answer for a.
1.956.
Very good. So this is your a, literally b answer from your calculator. So now what is my b here? Okay, that is, you got the answer from your calculator. That is my B answer from your calculator. Sorry, the A answer from your calculator. So I see my answer is 8.9596 and going all the way, and times e to the power -4 means 10 to the power -4. E means 10 here. So if you see, negative numbers in your power, that means you have to move the decimal place, in the number towards left. Okay, if it is positive, you have to move towards right. Now I have 4 here. That means you have to move 4 decimal places to the left. So this guy is supposed to be moved this way. 4 places, right? I already have 1 8 here, 1 place. So you have to replace 3, places here by putting 3 zeros. Therefore, 1, 2, 3, 0, right? My decimal was here. Now I'm moving to 4 place. So it's going to be now here, the decimal. So you want to put 1 0 there. So 8, whatever I left over, the remaining digits you could copy down here, 9596. Okay. So since this is a very, very small number, I'm writing, to some, more decimal places to get, the best answer. So I'm leaving my B answer as this much. Okay. Therefore, my prediction formula is 1.956 plus 0.000089596 times x. Okay. So now this is my prediction formula. Okay. Now we are going to predict what? Read the question. Find the cost of the gasoline when oil is
$60 a barrel.
$60 barrel. That means this is typically X value, right? This is your X. This is your Y. So X value is given. We are looking for the Y value, right? Y prime actually in my prediction. So Y prime is simply plugging X60 here. Okay. So that means 1.956 plus 0.0089596 times 60. So what is that? So that is, let us write in two decimal places because you see all the numbers here in two decimal place. So I'm writing in two decimal places. That is 2.01, right? So that is the gasoline price. Then you look at $60 barrel. Okay. So you should be good then. It's, this section is very brief section and we use the same procedure there. We use the data points, find A, B, and remember the formula. Okay, y prime is a plus bx. So your calculator will give you b and a. So you have to switch the values from your calculator to find a and b. Don't forget that. So that's it. So we are done with all the